So let me welcome all of you to today's very special, one-of-a-kind live webcast here at theprinciplemovie.com. My name is Rick DeLano. I am the writer and producer of The Principle. And today, I am extremely proud and honored and excited to be able to welcome for a one-of-a-kind live discussion the masterful mathematician, physicist, and philosopher Wolfgang Smith. Wolfgang Smith graduated at age 18 from Cornell University with majors in physics, mathematics, and philosophy. He received his master's degree in physics from Purdue University and his doctorate in mathematics from Columbia University. After pursuing a multi-decade career in faculty positions at MIT, UCLA, and Oregon State University, Dr. Smith retired to pursue a full-time career as an author. And he is well known, and as we are really beginning to find out since we have launched the website for his Philos-Sophia Initiative Foundation, well-loved in traditionalist and academic circles throughout the world, thousands upon thousands of people who have been following Wolfgang's work for many, many years and are so excited now to be in a position to contact him, to know that he is still with us. And as you're going to hear today, not only is he still with us, he is very much still working and presenting us with the fruits of his mature reflections upon foundational issues that speak directly to the questions addressed in the film The Principle. So welcome to you, Dr. Smith. Thank you so much for taking the time and giving us this tremendous treat to meet personally with you and to speak with you and to present you to the audience and some of your new work.
Well, thank you, Rick. I must say I'm embarrassed by these encomiums, but this is Hollywood after all. But I'm delighted to be facing a live audience, and we will try to have some interesting things to say, I hope.
I want to mention right off the bat that, as is the case with the principle itself, I fully anticipate that this one-of-a-kind live interview will very much bear repeated viewings. And because of that, oops, let's get rid of this. And because of that, we will be recording this interview, and we will be making it available and archived on both the Principle website, www.theprinciplemovie.com, which all of you know since you're here, and also at the website of Dr. Smith's exciting new initiative, the Philos-Sophia Initiative Foundation. That website is philos-sophia.com. So, Dr. Smith, one of the things that I have learned since we put the website up and started mentioning the fact that we have an upcoming documentary is that you have a very passionate and devoted following throughout the world. These are substantial people. These are people in high levels of academia, people in high levels of government who have been following you for decades and are just so excited and very happy to see that you have elected almost at the summit of your life to step out from what was essentially your seclusion over the past several decades. I wonder if you might address why it is that you have chosen at this stage of your life to step forward to launch the Philos-Sophia Initiative and to share with us some of the fruits of the new work you have been doing.
Well, to be honest with you, Rick, I have not chosen. I think you have chosen that for me, but I'm grateful because I do think that it is time to bring some of these basic insights and recognitions to as wide an audience as we can. I think there's a need for it, and the time is ripe. This is a moment in history where there is a reason for these, I would say, fundamentally metaphysical recognitions to be made available to the public at large.
Very good. Well, I just wanted to mention we are seeing our first question. What is Wolfgang's position on geocentrism? Well, definitely stick around, because that actually is fundamentally what stands at issue in the profoundly interesting new work that Dr. Smith has been working on. Now, how long have you been working on this new book that we can expect this summer, Doctor?
Well, it's a book on physics and metaphysics, and I've been working on it off because of interruptions, but not very long, about 4 months, I would say.
And this is a collaboration with the French metaphysician Jean Borel.
Perhaps many of you don't know the name Jean Borel. He's very, very fine philosopher in the traditional school in France.
And in the course of both preparing the upcoming documentary on your life and work, I think I had better turn this off. That's that. But in the course of preparing this documentary and writing the book, you have revisited some fundamental aspects of physics, as well as philosophy and metaphysics. And one of the things that I have always found interesting about your work, because I have traced this almost as an arc over the course of the decades of your work. When you first published back in 1984 with Cosmos and Transcendence, and even in the first edition of Quantum Enigma in 1995, one gets the sense that you simply accepted Einsteinian physics as if it were a given, and were quite satisfied to proceed on the basis that this was a valid physical theory. Is that the case?
Absolutely. I mean, like perhaps most people in the whole world, I regarded Albert Einstein's theory as a great breakthrough, something that is been verified empirically in various ways, and certainly all the great name physicists have accepted it and have applauded it as a wonderful theory. So you're absolutely right. I never critically investigated. I simply accepted this as a wonderful and validated theory.
And this is very interesting, because you get that sense when you read Cosmos and Transcendence, and while you get your first hint of a change in a footnote in the Quantum Enigma, a later edition, where you actually removed a chapter based upon your decision that there were some problems lurking out there in the Big Bang world. And you also, very interestingly, at a certain point in a later work called, well, it was originally released under the title of Ancient Wisdom, or the Wisdom of the Ancient Cosmology. It recently has been reissued, I believe, by your publisher under the title of Ancient Wisdom, Modern Misconceptions.
Yes.
Well, there's something very interesting here which shows some of this change that was already well underway and very easily discernible in your treatment of Einstein. You still accept it as a valid physical theory at this point, and I'm reading from page 160 of the old edition, the Wisdom of the Ancient Cosmology, which, by the way, you can still find online. It's still out there. But you basically say that, in what you term the physical universe, and of course this is a key to understanding your thought. Most people, when they hear the word physical universe, they think it's what we see, what we touch. Nothing could be further from the truth. What you term the corporeal world is the world of substantial forms, of qualities, of essences, of colors and sounds. Whereas the physical universe, you propose, in a very brilliant way, by the way, is in fact the universe as presented to us by the physicist. That this is not the world that we see, taste, touch, and hear. It's the world that we get when we take our microscopes and our measuring instruments and we go in and we do the procedures of physics. And that is a much different world. There's no color, there's no essence, there's no qualities. There's just quantities down there. And that distinction, of course, is the key to your breakthrough. It's the reason I'm making my next film, because I consider it to be a world-shaking breakthrough. But there was an interesting development right around the time, I guess this was around 2003 or so when you wrote this. You say a very interesting thing. You say, quote, "It appears that in a world defined operationally," and again, this would be the physical universe, the universe of the physicist, in what John Wheeler terms the participatory universe, Einsteinian relativity reigns supreme. But then you go on to say something very interesting. But how does the matter stand on the level of the corporeal world, the world in which we live and move and have our being? How does the matter stand on the level of the corporeal world? Do the principles of relativity apply to a world that is to be known not through acts of measurement, but through acts of cognitive sense perception? Do Einsteinian principles still apply in a world where essences manifest in the form of sensible qualities, a world in which not only relations, but actual substances are to be found? And then you say, there is no reason to believe that this is the case. So when I read that, I said, oh, there's a development going on in Wolfgang's thinking about relativity. But you have moved even further from this position, haven't you?
Well, to make a long story short, I have concluded on surprisingly simple grounds that Einsteinian physics does not even apply in the physical world. This is what I didn't know at that time. I fully believe it now.
And I think that brings us to our question, what is Wolfgang's position on geocentrism? I believe you have concluded that something very fundamental is going on in Einstein's 1905 paper, and it deals directly with geocentrism.
Well, I first studied geocentrism seriously in the works of people like Van der Kamp. Then at a later date, I was kindly sent a book by Robert Sungenis and Robert Bennett. It's an absolute classic in that field. It's a one-of-a-kind work, over 1,000 pages.
That's Galileo was wrong.
Galileo was wrong.
Right.
And this book, of course, was an eye-opener. I was quite amazed to hear about facts that I did not know anything about. And so the matter stood until quite recently when I was writing my book, the book in progress. And there I found that if you look at the very, very first steps which Einstein used in his 1905 paper to introduce the idea of relativity theory, some remarkable things come to light, very surprising things. And to make the story very short, it turns out that in order to affect his change, his relativistic physics, he has to alter the equations of mechanics. Classical physics involves mechanics, electrodynamics. Mechanics goes back to Newton, 1687, and electrodynamics came 178 years later. And Einsteinian physics is tailor-made to electromagnetic theory, but it doesn't really fit the equations of mechanics. So what does Einstein do to justify changing the equations of mechanics? What physical reason does he offer? And actually, when you winnow it down, he doesn't offer any physical reasons at all. Here's what is happening. He refers to the Michelson-Morley experiment of 1887, which was designed to measure for the first time the orbital velocity of the Earth in its conjectured orbit around the Sun. And to the great surprise of the physics world, the Michelson-Morley experiment did not detect such a velocity. It, in effect, measured it to be 0. So that was a big problem for the physics world. And in fact, I really surmise this is the fundamental problem the young Albert Einstein wanted to solve. And his so-called special theory of relativity of 1905 was his proposed solution. And it involved the idea that A, since this velocity is there, that was his assumption, and since the Michelson-Morley experiment did not measure it, therefore, his so-called principle of special relativity applies. And so he saw fit to change the equations of mechanics. And when you now step back and look at, you read his 1905 paper where he outlines his reasoning, and you look at this, you cannot but feel that the reasoning is circular. In other words, he took it for absolutely certain fact that the Earth moves around the Sun at such and such orbital velocity, and since Michelson-Morley did not detect it, ergo, principle of relativity.
In other words, they tried to measure it, they found the velocity of 0, and rather than accept the outcome of that experiment, Einstein decided to reformulate the equations that had served us well since Isaac Newton.
That's right. In other words, because the equations of mechanics did not fit his theory, so therefore you change the mechanics. It's a Procrustean solution to the problem.
The Procrustean. The reference there is to a wonderful story where Procrustes, whenever anybody got into his bed, if their feet were too long, he'd just hack them off, and in that way he could say everything fits. You know, everything fits. That's the Procrustean solution.
That's the Procrustean. So this is how the matter stands on a theoretical basis. Now, in thinking about this, I came upon a perfectly obvious fact of classical physics, which, however, to my knowledge, no one had ever bothered to spell out. Now, the fact is this. If you have a reference frame K0, let us say, and with respect to this reference frame, the equations of physics, mechanics plus electrodynamics hold, and if you then find another reference frame K in which this is likewise the case, then it follows that K is stationary with respect to K0.
That's profound, yes.
The amazing thing is that it is so obvious, and I don't remember anyone ever pointing this out and giving it a name. I call it the principle of immobility. And it's a remarkable fact, namely, our equations of physics, classical physics, actually define a notion of stationary reference frame. The idea of the stationary is there, implicit in our physics. And so Einstein, of course, knew this very well, but he couldn't accept it. We'll talk about this in a moment. Why didn't he want to accept this? And so he introduced his principle of relativity in order to deny the principle of immobility. So when I recognized this, I was quite amazed, and I asked myself the natural question, what is it about this principle of immobility which offends Albert Einstein? Why is he so dead set against it, when actually, winnow it down, there are no empirical facts which contradict it?
That's right. It's not like the problem that we faced was that the Michelson-Morley experiment was supposed to yield a 30 kilometer per second motion, and it didn't. That was the problem. So you can either adjust your assumptions about that orbit, or you can rewrite the equations for physics to fit a theory that explains it away.
I mean, to find fault with the Michelson-Morley experiment is like shooting the messenger. I mean, they measured something, the verdict was in, and they don't accept it. They say something strange must be happening because we know the Earth moves. In any case, thinking about this, I realized that there is a very close connection between what I call the principle of immobility, the fact that physics, classical physics, singles out the so-called stationary reference frame, and geocentrism.
There's that dreaded G word again.
There is just one detail that needs to be resolved. It is generally believed that the Earth rotates around its polar axis every 24 hours. And therefore, from this point of view, it cannot be regarded as stationary. But it so happens that a physicist by the name of Ernst Mach came up with a principle known as Machs Principle. Incidentally, that's Einstein's designation. He called it Machs Principle. And he was very inspired by it, and I think his general theory of relativity was to some degree motivated by that. But what Machs Principle tells us is that you cannot really distinguish empirically by means of experiment whether the Earth is rotating and the cosmos is at rest, or whether it's the other way around. There's no conceivable way of putting this to the experimental test. So in other words, one is at liberty to take the geocentric reference frame as being at rest. And now when you combine this with the principle of immobility, you find that classical physics combined with Mach's principle gives you geocentrism. And once I recognized this, it was quite clear to me why Albert Einstein was so eager to reject this principle of immobility, or not even to name it, not even to explicitly point out what it is that classical physics really has to say on this question. And so I realized that it is the antagonism towards geocentrism that stands behind the whole phenomenon of relativistic physics. And it reminded me of a very interesting thing that a scientist by the name of Richard Lewontin said. He wrote somewhere, speaking for the scientists, he said, "We cannot allow a divine foot in the door." And I really feel that hits the nail on the head, because if you speak about geocentrism, if you speak about the idea of the earth being at rest and defining rest. What is implicit in this idea is the notion of design. So there's design in the universe, and design obviously entails a designer. So I came finally to the conclusion that relativistic physics is based, strictly speaking, not on empirical evidence, on strictly scientific considerations, but at bottom it is ideological. And the ideology is contra the idea that the world was designed by God.
Profound, very, very interesting. Now, we are going to be given the tremendous experience of having Dr. Smith walk us through the precise steps in his examination of the Einstein 1905 paper in a moment. I want to take just a minute here to address a question that has come in regarding microwave emissions from our oceans interfering with the results of the CMB images. I'll go ahead and answer that because I've looked into this. It's preposterous. What this idea requires us to believe, first of all, is that what Kobe measured through a closely, very small aperture pointed in directly the opposite direction was microwave emanations from the oceans that were 90 miles below and directly behind the measuring instrument. That alone is enough to put paid to that notion as far as I'm concerned, but it gets worse. Subsequent missions to map the microwave background were not 90 miles above the Earth's ocean. They were at the Lagrange point, the second Lagrange point, nearly 1 million miles away from Earth. And yet they saw the same microwave sky. We would urge people to consider that it is completely impossible that the picture of the microwave sky, which has been returned to us now by 3 separate missions, 2 of which were at the second Lagrange point 1 million miles away, or nearly 1 million miles away from Earth, could possibly be picking up anything emanating from the Earth's ocean. So that will deal with that particular question. Let's go ahead and step back now to that fateful 1905 paper. So one thing that you and I have both talked about is that, and I feel this too, I've read Einstein many times where the feeling that I got from him was, here is a real thinker, a real physicist. He's honest. He seems to be incredibly thorough. I've shared a couple of anecdotes where I would be reading, somebody would bring him an objection to the continuum. And I would read his response, and I was very impressed by it. And you always seem to have the same analysis. But you say you've found a departure from that degree of rigor and clarity in the first 2 paragraphs of this 1905 paper. Could you share with us what that is?
Well, I'm sorry to say that when you read the first 2 paragraphs of the 1905 paper, you find, first of all, that Einstein does not speak with his accustomed clarity. The man was incredibly precise, incredibly accurate with all his affirmations. And at the critical point in the 1905 paper, there's a certain ambiguity. I mean, for example, he lumps mechanical and electromagnetic phenomena together in a way which is misleading, considering the fact that these are entirely 2 different domains. The equations are invariant under entirely different groups. One really has the impression that he is trying to minimize the difficulties. He's trying to make his step far more innocuous than it really is, and the main thing is the argument via Michelson-Morley, the circular argument where, because Michelson-Morley didn't detect a postulated speed, you shoot the messenger. You use this as really the only justification that I can find, the only physical justification for changing the equations of mechanics.
And the significance here is really quite profound, because we know there is one reference frame where the equations for mechanics and the equations for electromagnetics work beautifully without any futzing around or anything else. And that happens to be this one, the geocentric reference frame.
Yes.
And we did physics quite well without having to rewrite the equations for mechanics. And there's a little dipsy-do there, isn't there? Because he refers in the first paragraph to certain asymmetries that do relativize in the electromagnetic domain. And then he makes a fundamental shift to the failure of all experiments to detect the orbital motion of the Earth. Yeah. He's done a little jump out of one and into the other there. Yeah. And then he says, things of this nature lead one to suppose that there is no such thing as absolute rest. That's a little bit of a dipsy-do there, isn't it?
Yeah, and also, for example, he is very much the heliocentrist. And as a relativist, it should be perfectly plain to him that you can put the origin of your coordinate systems at the sun, or the center of gravity of the sun, planet, two-body system. But you can equally well put the origin of your coordinate system at the Earth. So why is there this absolutely, in a sense, uncritical postulation of heliocentrism? He speaks of the Earth moving in an orbital velocity of 30 kilometers per second around the sun. Why not equally well speak of the sun moving with such and such orbital velocity around the Earth? Things don't really quite add up if you read the initial paper on relativity theory objectively, without any kind of relativistic prejudices.
Well, and that's what we've come to expect from you, Doctor, because it is this same dispassionate, just looking at the facts and following where they lead, that led you to your truly remarkable resolution of the quantum enigma. And we're not going to get into that so much today, because that's the subject of our documentary film, and you do not want to miss this, is all I can tell you. But there is a question that has come in here, which I will, I'm a little confused here, because the questioner asked, Dr. Smith, elaborate on what has driven you closer to the works of Bohm. I assume he means the physicist, David Bohm. And I don't believe you have been driven closer to the works of David Bohm. And so that answers the first part.
Well, I would just say about Bohm, Bohm did ingenious mathematics to try to stay with Einsteinian relativistic mechanics in the face of quantum theory. And it took an absolute mathematical genius to do that. You have to introduce all sorts of very esoteric sounding ideas, this pilot wave. But the end result is that it's all on paper. There's no way of actually making physics out of that.
Exactly.
So
the second part of the question is interesting. Are there any problems posed by the discoveries of contemporary physics that remain unanswered by Thomistic philosophy?
Well, Thomistic philosophy gives us the answer to the absolutely foundational problem. The world today believes that when you pick up some material object in your hand, like a piece of rock, it is simply an aggregate of quantum particles. And I think physicists have a tendency to actually assume that this is a scientifically established fact. Now, of course it isn't. And if they would bother to think about it, they would understand that it isn't. But Thomistic philosophy enables one to conceive of what I call corporeal objects, which are more than just an aggregate. Of course, I mean, there is such a thing as fundamental particles, and they do have something to do with corporeal reality, but corporeal reality is something more, and that something more can be very beautifully conceptualized in Thomistic terms as a so-called substantial form. This is what changes an aggregate of fundamental particles into a perceptible, real object.
And this obviously is another example, I think, of what makes your thinking so unique and so interesting. Of all the hundreds of different quantum resolutions that have come down the pike in the last 100 years, I think you are the only one who had the mathematical and physics background necessary to understand the issue from that side of the fence, and a sufficient background and understanding of Thomistic philosophy to do the one thing that only Werner Heisenberg seems to have even,
He came within a hair's breadth of seeing the whole picture.
Yeah, and that was to apply the idea of substantial forms, which is well known throughout all the educated schools of the world, up until Descartes and the beginning of the what I would call the scientistic era. All of them understood that matter and form, you got to have both. If you want to have a glass, you can't just have the matter, you can't just have the potentia, you can't just have the particles. No. There's got to be something that makes it more than just particles, and that is, of course, the substantial form. So this is another example of you taking your method of approaching these things and thinking it through in ways that yield astonishingly simple. I mean, your resolution, there's one thing about your resolution of the quantum enigma that is absolutely unique in all the world. It's almost unbelievably simple.
Absolutely. I think you've hit the nail on the head. I see things that other people don't see because it's too simple.
Well, that's a very good thing. Let's see, we have another question coming in here. John's Revelation book says the designer will live here on earth. Seems like the earth is. Well, the questioner is perfectly entitled to point out that it seems logical to him that the resting place of the designer here on earth would be at rest, and that the cosmos thus moves. It is perfectly reasonable. As a matter of fact, the greatest minds in human history in the pre-scientific age were perfectly aware of the possibility of a heliocentric solution being applicable as well as a geocentric. And they came down on the side, I'm talking about Aristotle and Plato, for example, came down on the side of the geocentric model for just that reason, that they considered it to be a more comprehensive and accurate view of reality, to consider the geocentric view to be right for us. And Wolfgang, of course, has approached it from both that position, but also from the position of physics itself.
Yeah, but let me just point out that the way the ancients understood heliocentrism and geocentrism, they realized that there's no contradiction between the two. These are two different ways of looking at reality. Both are necessary. Incidentally, this is something that I found so wonderful when I was acquainting myself with what we in the West call Indian philosophy. The Sanskrit word for philosophy is darshana, from the word drish, to see. And so a darshana is not a philosophy as we understand the term, it's a point of view. In other words, to see something you have to look, and that requires a choice of direction. And there are, in the nature of things, 6 fundamental directions. And so in India you have 6 darshanas. And the one that is regarded in a sense the highest is called the Vedanta, but it's the highest in the sense that it points directly up. But that doesn't mean that the other 5 directions aren't also necessary. Each has its own message. So we in the West, in modern West, I don't think that was true in Greek times, but in the modern West, we have this either-or philosophy. The Hindus in that regard are much wiser. They realize it's not a question of either-or. There are different ways of looking at things, and they all have their truth, and they all also, by the same token, have their limitations. So heliocentrism and geocentrism are 2 darshanas, and they're both true, each in its own right. And the important thing that was quite clear, I think, in ancient times was that, in a sense, the heliocentrism is exoteric as compared to the geocentrism, because what we actually perceive through the senses corresponds obviously to geocentrism. Here we stand and we look at the universe. So the heliocentrism is a higher way of looking at things, where you look not with your senses but with your intellect. And there the sun is at the center of the universe, because the sun is the cosmic manifestation of God. It gives light. In a sense, it gives being to all that is in the universe. So heliocentrism has its own truths, but on a physical level, in relation to the equations of physics, it is false, demonstrably so.
Very interesting. Also, this is kind of important. The question I asked earlier about you getting closer to the work of David Bohm, the questioner did not mean David Bohm, but Jakob Böhmer, which is a horse of an entirely different color.
Well, to be honest with you, I would just as soon not get into Jakob Böhmer at this point, because it is so difficult, and it is so, especially in regard to the Catholic world, it is something that will require a great deal of preparation and explanation to bring across in the right way.
Oh, perfectly understood, absolutely. Now, we have a question coming in now. Dr. Smith, is there any kind of experiment that could lead to the empirical knowledge about geocentrism? Well, I think you've just spent the last 20 minutes telling us about...
Yeah, our classical physics, which obviously is based upon empirical experiments, actually stands on the side of geocentrism. It singles out geocentric coordinates as stationary, and these are the coordinates, and these are the only reference frames in terms of which these equations hold.
And just to really hammer this home, because it's so simple that you could miss it. We have the equations for mechanics we've had ever since Newton. They work beautifully. We have the equations for electromagnetic phenomena, which come from James Clerk Maxwell about, what, 100 and some odd years later?
178.
Oh, nice.
I'm just writing a book.
And there's one frame in which we know those work just perfectly. They don't need to be transformed. They don't need to be rewritten. They don't need to have square roots of -1 v squared skis. They work just fine. That happens to be the geocentric frame.
Yeah.
So when you look at that and then you see, gosh, we did an experiment to measure the motion of the Earth around the sun and we didn't get any. I know, let's rewrite the equations to explain that fact away. The empirical evidence is clearly starting to...
As a matter of fact, let me interject something which I think is interesting. I said a few moments ago that you can just as well take the origin of your coordinate system when you're trying to calculate the motion of the sun and moon and stars centered at the Earth. Well, in, I think it was 2013, a physicist by the name of Luka Popov wrote a beautiful paper where he did just that. To the best of my knowledge, he's the first physicist to do that. It's not easy, by the way, because you have to use Newton a la Ernst Mach. You have to invoke the Machs Principle, and then you have to use a Tychonian system, otherwise the equations get out of hand and so forth. So it's technically challenging, and he did it. And I think it should be widely known, because this also sets the whole question at rest. There is no reason on Earth to believe that heliocentrism is physically correct.
Now, another point that I would like to make about Dr. Popov's paper that's really quite remarkable. Dr. Popov published that paper after a very interesting peer review process. It was published in the European Journal of Physics. And Dr. Popov was standing for his doctoral examination when this paper appeared, and just, woo, you know, he was challenged on this, and he was challenged on that, and he was challenged on stellar parallax, and he just calmly went about using the mathematical precision to show that these challenges were invalid, and his paper withstood all of these challenges and remains published in the European Journal of Physics today. What I'm very happy to say is that Dr. Popov got that doctorate. You know, he was able to stay in the saddle against the rather severe buffeting that his paper got. And Dr. Popov is now a doctor of physics and made it all the way through, which I think is a marvelous thing, because as those of us who have been following the work of Dr. Sanjanis and Dr. Bennett for years have known, the evidence is really mounting not just at the level of fundamental physics, but also, as we cover in the Principle, at the level of cosmology, at the level of the universe on its largest observable scale. No. There is evidence coming forth that is just astonishing to those who have come to believe in the Big Bang story of creation. I wonder if you might examine or share with us your examinations of some of these other evidences concerning the relativity theory.
Well, if you want to jump into the cosmology, this is in a way the most exciting application of, in this instance, general relativity theory. Incidentally, if the special theory falls, the general theory falls too, and it's my belief that the special theory has fallen. It does not square with the empirical evidence. So then neither does the general. Well, based upon general relativity, as I think our audience is well aware, perhaps the longest, most expansive research project in the history of mankind has unfolded, leading to the so-called Big Bang cosmology. And so now every school child knows that the universe reputedly is so many billion years old. So let us consider a little how this theory has fared. Well, the fact of the matter is it really has fared very badly from the beginning. In other words, early on, it turned out that these facts don't fit. That was remedied. Another set of facts don't fit. For example, it was found that the expansion of the universe within the first second is not fast enough to make everything work. So a very brilliant physicist invented something called inflation, which incidentally now is in big trouble. But the point that I want to make is that this technique of introducing what is technically called ad hoc hypotheses. Ad hoc means as much as picked out of thin air. There's no reason. You make this hypothesis, you postulate it precisely to remedy some problem. And this has been going on. So every time an ad hoc hypothesis is put in place, another problem arises, another ad hoc hypothesis appears.
It's not calculated to give one the greatest degree of confidence, is it?
One of the distinguished astronomers of our time, Brent Tully, put it rather in a funny way. He said, it's disturbing that every time there's a new observation, there's a new theory. But it really is true. So this technique of remedying difficulties through the introduction of ad hoc hypotheses is a very questionable thing. It is a technique, incidentally, which has been used for a long, long time to keep Darwinist evolution theory in business. So time and again, when a problem in this part of science comes up, you very ingeniously discover an ad hoc hypothesis which keeps things going. Well, another example in cosmology, there's not enough matter in the universe to have gravitational fields strong enough to explain the formation of stars. So you solve the problem by inventing something called dark matter. And I must say I admire the mathematical prowess of these geniuses who come up. They have all kinds of interesting names like gluinos and
quark nuggets.
In my book, just for fun, I list a whole slew of these names. It's rather funny in a way. But the point is, these exist on paper. Nobody has ever discovered any such particles. So this process of ad hoc interventions goes on, and it keeps the theory alive. And I really consider it a very interesting question in the philosophy of physics. What is to be said about the end product of such a process? Have you then discovered a truth, or have you created a fantasy? I think it's a very interesting problem. To my knowledge, nobody has given us the answer. But the fortunate thing is that in the case of Big Bang cosmology, we don't need to answer that question, because something happened in the way of empirical findings which ends this process. Something happened which no ad hoc hypothesis can remedy. And you're the expert on this, and as I think most of the people in the audience here will be well aware, I'm referring to the so-called axis of evil, so named because it really does put an end to Big Bang cosmology. And so first this appeared in a kind of imperfect form. Another satellite was sent up to completely solve the problem.
Vague hints of it. Max Tegmark told me that there were just vague hints of something fishy for the COBE satellite. Then they sent up the Wilkinson microwave anisotropy probe. That was specifically designed to look at these fishy things. And boy, that's when the axis of evil really gets going. And it's called the axis of evil for very good reason, just as you said. It causes big headaches for anybody who's trying to prop up standard Big Bang cosmology. But the key, and this is, of course, one of the really great moments in the Principle, is that they sent a third. They sent a third mission. This one they called the Planck Mission, after Max Planck. And I'm sure he was happy as a clam when the results came back. And not only is the axis there, but it's no longer possible, as Max Tegmark said, you know, when the microwave axis was first discovered, Max was absolutely persuaded that there was something wrong. They showed it to be aligned up with the ecliptic of our solar system. There's no way. There's got to be something fishy in the data. But as he says brilliantly at the end of the second interview he does in the Principle, he says, you know, but I have to have my brain override my gut. My gut was telling me there was something wrong, but the data, it's there. Now, reasonable people can argue about what it means, but it's really, we're past the point of arguing about whether it's there. And what is there now is a special direction. Well, that's hideous news for a Big Bang and for basically an Einsteinian covariant universe where every reference frame is supposed to be just as good as any other. But it's much worse than that, because the special direction is not just any special direction. Why don't you tell us about that special direction?
Well, this is a worst-case scenario. It's adding insult to injury. This great circle in the CMB, in the cosmic microwave background, which has now been documented beyond any possibility of doubt, it happens to line up with the ecliptic of our solar system.
Just amazing.
So we have to recall in the Einsteinian universe, the Earth is a random speck within a galaxy which is itself just a random speck. So this speck within a speck now controls the global geometry of the cosmos.
Divides the whole cosmos neatly in two.
Yeah.
And that is so astounding. And I must say, Principle has been finished for almost 4 years now. And you can still find nothing that really shows you the significance of that ecliptic alignment, like the wonderful fly-through animation that Bouffe Compagnie Paris did for that film, and which remains the only place in the world where you can really see the significance and how stupendously unpredicted and, frankly, unwelcome.
That's an understatement.
It's funny. Let's take a look at a question that you might want to take or may not. One of our readers, one of our watchers writes, how does Wolfgang's work on the quantum enigma compare with the work of Anthony Rizzi, founder of the Institute for Advanced Physics, which seeks a return to Aristotelian principles in understanding reality in physics? Are you familiar with Professor Rizzi?
I never heard of him.
Okay. So how do you feel about a return to Aristotelian principles in understanding reality in physics?
Well, I mean, the Thomistic principles are, in a sense, Aristotelian, and the basic concept, the distinction between form and matter. Of course, the notion of a substantial form, as you find it in St. Thomas, is an evolved concept, but based upon Aristotelian. So I really don't make any hard and fast distinction. It's the same basic school of philosophy.
Right.
So it has served me well. I'm absolutely convinced that the idea of substantial form is crucial, because without substantial forms there is no being. And without being there's nothing. Not even quantum particles.
There you go. Here's an interesting one. We'll let you take a quick look at that when okay, I think it's up now. Does substantial form answer the Kantian disjunction between the thing in itself and mere appearance?
Well, I must say at the outset, I am totally opposed to the philosophy of Immanuel Kant. I think he has done a terrible damage to philosophy. The post-Kantian era in philosophy has been sterile and has been given rise to all sorts of pseudo-philosophies, which I'm sure in course of history will disappear without leaving a trace. It has muddied the waters because the idea of the thing in itself is really a kind of mental phantom. Show me a thing in itself, and if you do, it won't be a thing in itself anymore.
And of course, recently on the Philos-Sophia Initiative Foundation website, a magnificent contribution from one of our board members, a philosopher and a close associate of Jean Barella, Bruno. What is Bruno's last name?
Berard.
Bruno Berard. Forgive me, Bruno. He's probably watching.
I hope he is.
You'll get your pound of flesh on this one. But Bruno wrote an absolutely scintillating article called Unmasking AI, Unmasking Artificial Intelligence. If you haven't read it yet, you must, because Kant is just the deft little sword stroke on Kant in there, and what Kant did to remove the intellect and replace it with the rational faculty answers so much of what's going wrong in our civilization.
Very important.
Very important paper.
Yeah.
And by the way, there's so many. We have a wonderful three-part series on vertical causality by the Brazilian physicist Dr. Rafael de Paola. We have another physicist from Turkey who's writing a paper on Wolfgang's work. There is such great material coming up on the Philos-Sophia website all the time. Bookmark it and give us your email address, because it's getting harder and harder to find you guys on Facebook. They're not making it any easier for, outsiders and non-mainstreamers, believe me. Here's an interesting one. Look at all these interesting names that are popping up in the questions. We have a very, very high-end audience here today.
Oh, I'm impressed.
And the question is this. As a mathematician, did Guénon, as you being a mathematician, I'm sure he means, as a mathematician, did Guénon get everything right in his Principles of Infinitesimal Calculus? That's the first one.
Yes, I strongly believe that this is a book that is impeccable and very, very fascinating. And one of the things that fascinated me especially about the book, Guénon, as a rule, was very critical of modern science,
yes,
even of physics, which he only partially understood. And so he said some things about physics which are true, he said some things which are not true. In the case of mathematics, he is spot on, as they say. And I remember one thing in particular, he was talking about the Riemann integral. And he said it is the perfect symbol for, well, I don't remember the term he used, but we can say gnosis, that supra-rational knowledge of whether it is the cosmos or the self. It is like a flash of lightning where you see the metaphysical, or you could even say mystical truth at a glance. And to Guénon, the Riemann integral was a perfect symbol of that. I was very impressed. You see, after all these years, I still remember it now, so I must have been impressed, because I think it was a very profound insight that he was enunciating.
And here is a very interesting question. Dr. Smith, do you know the work of Brazilian philosopher Olavo de Carvalho?
Indeed I do, and I must say, the more I learn about Olavo de Carvalho, the more deeply impressed I am of him, not only as a philosopher, but as a... It's so hard to find the right word, because whatever word comes to my mind, it's insufficient. I could say a patriot, I could say a defender of human civilization. I understand that he's had a tremendous impact in Brazil. He has thousands and thousands of followers. He's had a great influence, all in the right direction. I think the leftist regime in Brazil was not fond of him in the least. But in regard to my own work, I'm honored to say that Olavo de Carvalho has had an interest in my writings. I think he's read them all. I think he and I are very much on the same wavelengths. And one of our good friends now, Dr. Rafael de Paolo, a theoretical physicist in Rio de Janeiro, is a disciple, you might say, a student of Olavo de Carvalho. And so I have very friendly feelings and high respect for the school of Brazilian philosophy and enlightenment.
And I just want to mention once again, Dr. De Paola, that Dr. Smith just mentioned, has been so incredibly generous to provide a marvelous primer on form and matter and vertical causality. It's a three-part series. It's designed for the beginner. It's designed to get you up to speed. What the heck do they mean matter? What the heck do they mean form? What the heck do they mean vertical causality? And Dr. De Paola was so marvelously generous to take the time to give those of us who need a step up into this. It's a three-part series. It's on the Philos-Sophia website and is very, very much worth your consideration. So, we have another question here. By the way, I'm very impressed with our questions.
Amazing.
I mean, wow. And this is, I must say, you know, we may be small still, but we're not as small as we used to be. But the caliber of people that are being attracted into the discussion here at the Principle, over at the Philos-Sophia website, I am a little bit intimidated because I'm not nearly as smart as all of these people. Am I still gonna have a job here, boss? Anyway, let's take a look. Okay, the question is, I argue that since we are in the middle of the universe and subject to gravitational fields, we cannot know experimentally whether we are moving or not in an absolute sense. That requires revelation. So this is a very interesting point. One of the participants in the Principle, Dr. John Byle, is one of these guys who accepts relativity, says, we can't tell whether we're moving or not. Therefore, I am a geocentrist, but on grounds of revelation rather than physics. I always thought that to be a perfectly valid way of looking at it. What's your response to that?
Well, in light of what we said earlier today, the fact is that classical physics, together with Machs Principle, tells us that the Earth is at the center of the universe. It is stationary, it is at rest, and the cosmos at large is revolving around it every 24 hours. So, therefore, I am persuaded that you do not require revelation to tell you this fact.
Wow, that's a profound insight from Dr. Smith. For Dr. Wolfgang Smith, that is the penultimate step on your climb up the mountain here.
I mean, it squares with revelation because there's no question that. I mean, for example, in the first few verses of Genesis, you learn that the earth was the first created cosmic object before the sun, moon, and stars. So this already, if you have any sense that that Scripture is true and it is the Word of God and it is inerrant, then that ends the question right there. How can you not be a geocentrist?
It's amazing to me. You know, I remember once when we were screening the principle, trying to find some friends. We didn't find any, but we screened it for an outfit that's sort of anti-evolution, Bible fundamentalist Protestants back in Denver, and I recall that I ran into some very stiff resistance on the dreaded G word. Matter of fact, I was told in no uncertain terms that if I didn't get reference to that dreaded G word out of the principle, I was going to get no friendship and no love from them. And I wasn't expecting this. I mean, it was a bit of an ambush, you know.
Yeah.
Which I'm sure that Dr. Sanjak and I and Dr. Bennett and others, we've learned to expect these. You know? Sure. But I remember that the time was short, and so I just said, I'm among Bible Christians. What's the best answer? I said, has everybody got a Bible here? And of course they all do. One thing you can say about those guys, they got their Bible with them. God bless them. I said, can you all open it to Genesis 1:1? Can you read what it says? Just go ahead and read it out loud. In the beginning, God created the heavens and the earth. I said, do you believe that? Oh, yes, yes. Do you really? Oh, yes, yes, yes. Case closed. I have nothing more to say about geocentrism. It's there in Genesis 1:1. And I have to tell you, it was really funny. Against their own, you know, leaders, they bought it right then and there. They were as happy as could be with that explanation of geocentrism. So, yeah, that's interesting.
Of course, if I may make a parenthetic comment here, one has to be a little careful in using Scripture to prove this and that. Because, I mean, take the example that you just gave. In the beginning, God created the heaven and the earth. Well, there are so many ways of interpreting that. Meister Eckhart says, here heaven means form and earth means matter. And that is also true.
Oh, yeah.
So the problem with people, I say God bless them, they believe in the Bible, and so do we all. But you have to know what you're doing. You can't just blindly and in a the word fundamentalist has been weaponized and used in very invalid ways, but it also has a certain validity. There is a kind of fundamentalism,
which, by the way, brings me to a very important point I would like to make, and I promised Dr. Sanjak I would do this today. Speaking of fundamentalist interpretations of the Bible, well, it will come as no great surprise, I'm sure, to my audience here that one very large and fast-growing group, they're growing much faster than we are, God bless them, are the flat earthers. And I think I can safely say that the principle has been hacked hundreds of thousands of times just that we know about. I mean, we're going around pulling them down off of YouTube all the time. Hundreds of thousands of times by flat earthers who are delighted to have the arguments of the principle to buttress their fundamentalist readings of Scripture concerning the flat earth. So, big news. I have it directly from Dr. Sanjak himself. He is about maybe 3 to 4 weeks away, he says, from the completion of his next book, which will be the comprehensive 600-page total takedown of the entire flat earth, whatever you want to call it. And you know how Bob does these things, you know. Nobody does the heavy lifting like Bob does. He will literally exhaust every argument they have. So, and Bob tells me he's going to do a webcast on the Principle site just as we are today. I'll keep you posted, but mark your calendars. Bob Sungenis is coming, and he has something to say about flat Earth, and I suspect it will be comprehensive. And God bless you, Bob, because I just don't have the patience. I just don't have the patience. Now, we have another interesting question here. In the book, In Quest of Catholicity, by the way, this is Wolfgang's most recent book put out by Triumph Communications.
No, this is the one that preceded it.
Oh, I'm sorry.
Yeah.
That's right. I'm so sorry. Pardon me. A pilot error. In the book In Quest of Catholicity, this is the interviews with the correspondence with Malachi Martin. In the book In Quest of Catholicity, Smith wrote, quote, "How little we know concerning the higher function of animals. I am tempted to say their spiritual side, and of their connection, above all, with the angelic realm," end quote. Does Dr. Smith think the new finds of quantum physics will change St. Thomas's view that the souls of brute animals don't subsist after death? Now, there's a radioactive question for you, Doctor. How brave are you feeling today, sir?
Well, that was taken down, but the reference was to quantum physics.
Whether quantum physics,
there
we
it
go.
is. Yeah, well, quantum physics really deals with a sub-existential domain. So quantum physics really has no relevance to this question, because the question is whether what we can say about the spiritual side of animals. I was very fascinated when I learned rather late in life that the archetypes of the animals pertain to the angelic order. And for example, it explained to me why I personally have such a tremendous aversion to snakes. I mean, objectively speaking, it's an animal like any other, rather interesting in its geometry, but why should one cringe from the least contact with this animal? Well, as you know, if you're a Christian at least, you know that the angelic order divides into two segments. They're the true angels and the fallen angels, and the fallen angels are responsible for the greater part of the misery of our earthly life. And certain animals then actually are connected with the higher centers in the angelic order, and especially something like a dog. Father Malachi Martin had that wonderful relationship with a little Cairn Terrier who was there in his room every morning when he said Mass and so on. And it's a fascinating, he's written something about it, which God willing I'll be able to publish. I have a copy of it. It would be a marvelous book, and it chronicles the relationship between this priest and that little dog. And it is a beautiful relationship because actually you can call it a spiritual relationship. There was something on the mystical order passing between these two creatures of God. And so I touch upon that in the book, and I'm happy to see that some readers are interested in that.
Beautiful. Now, we have a question. What about redshift and blueshift, the pattern in the universe discovered before the Planck missions, etc., that pointed toward the Earth being the center of the universe? Well, I'm sure he is referencing the Hubble.
Yeah. Well, let me just say real quick that the Doppler interpretation of the redshift, which has been sort of standard scientific lore for a long time, is something that is very much in question. An American physicist, what was his name? He was
Halton Arp, I think, wasn't it? Halton Arp?
Yeah, yeah. He was one of the top experts in
Astrophysics.
quasars,
yeah.
And he said that there's a great deal of evidence now to the effect that in quasars, for example, the redshift is not a Doppler effect. And so the whole idea of Doppler effect, it was a very convenient way of explaining this shift towards the red side of the spectrum, but it is very much in question, and it would not surprise me at all if, say, 10 years from now, it were a known, accepted scientific fact that there is no redshift at all, in the sense of Doppler effect.
Well, it's a very interesting thing. The more I look at this, there are certain problems in astrophysics that are solved beautifully on the assumption that redshift is a distance indicator or a recession indicator. But there are just exactly as Halton Arp pointed out, when you have a physical connection between a quasar that's supposed to be billion years old and a galaxy that's supposed to be much younger and much closer, you start wondering. And of course, the simple fact is, as Hubble discovered, when you look out at all of these galaxies, and later on as we got more powerful telescopes, the quasars and so on, we're at the center. I mean, if you assume that it is a velocity indicator, it puts us at the center. And of course, we covered this in the principle, and this was another genius intervention by Uncle Albert himself to say, okay, it looks like we're in the center, but we can't be in the center. Ah, I know. Expanding four-dimensional space-time.
This Einsteinian strategy of making everything equal.
Yes, exactly.
Here at Earth, for example, we may see everything receding from us. Well, Albert Einstein says, well, everybody is the same. If you put yourself on the moon or on some remote place in the galaxy, you will have the same thing. And I must say it's very ingenious. If you are living on the surface of an expanding balloon,
then
wherever you are, your neighbors are going to be moving away from you if it is expanding.
It's brilliant.
So it's brilliant, but
it's ad hoc.
It is ad hoc, and I was really amazed, and I thank Dr. Robert Bennett for making this vast literature somehow accessible to me. I was amazed to see how absolutely non-existent empirical verification of Einsteinian physics is out there. In fact, the fact is there's really nothing out there. I'd like to make one remark because I think perhaps for many viewers this may come as a surprise. One of the most convincing, quote, confirmations of relativity is the famous formula E equals mc squared. And we all know, tragically, that this formula is true and dead accurate. Well, what is the story about that? Einstein derived it from his theory of relativity, special theory, and this is true. We can do that. What he did not tell us is the fact that this formula follows directly from the Maxwell equations, which existed ever since about 1848, and in fact had been picked up by physicists in the 19th century. I understand there's some obscure journal someplace where this formula has actually been derived. The point is that it has nothing to do with relativity theory. But hardly anyone knew this. I didn't know it. I mean, I was among the duped people who thought that this was confirmation with a bang, a very big bang.
Yeah, exactly.
And it was not until 1950 that Einstein confirmed that in one of his writings. He he said, yes, that can be derived from the Maxwell equation. In the meantime, the damage, I would say, was done. The whole world had become Einsteinian.
Well, you know, this raises a very interesting theme that recurs in your work over and over again. The distinction between science and scientism. And this is a very profound part of your work because unlike Guénon, for example, you do not reject the scientific method and you do not reject the fruits of the scientific enterprise, quite to the contrary. On the other hand, you have very short shrift for what you term the mythical encrustations that are added to these scientific facts to become this scientistic myth, if you will.
Well, I would distinguish between scientism and, what shall I say, a word that doesn't sound too cruel. It's deception, and these are two different things. Now, I'm sorry to say that deception has occurred in various scientific domains. It used to be very rare. Now it's sort of the standard thing. And let me give you one example of this, which I think is really astounding. Among the experimental effects which are known to be true, which do contradict Einsteinian relativity, is the Sanjak Effect, which was 1913 that was published. You had an interferometer mounted on a rotating platform, and it splits the light into two beams. One goes with the rotation, the other counter to it, and so the one turns out to be superluminal, and the other turns out to be subluminal, and this goes against Einstein. Now, you may say this is a non-inertial reference frame, so you are talking general relativity. Well, later, somebody by the name of Wang,
Ruyang
Wang made a beautiful experiment where he did essentially the Sanjak effect, but instead of a rotating platform, he had a platform in rectilinear motion. He compared light beams going with the motion. Same thing as Sanjak, he modestly called it a generalized Sanjak effect, otherwise nobody would have published it. And
I must say that I've never met Ruyang Wang, but if I ever got the chance, I would shake his hand and say that is the most brilliantly thought of title.
Diplomatic.
Diplomatic, because essentially it's challenging a fundamental premise of Einsteinian physics, and the word relativity never appears in his paper.
It would have never been published.
It never would have been
published. Because I think most people, even in the skeptical age, would be amazed to realize the amount of deception, actual deception. And I learned about this recently from Dr. Robert Bennett's writings. Let me just recount that briefly. In the so-called GPS or global positioning system, this is really a laboratory ideally suited for testing Einsteinian effects.
Yes.
And the operation of GPS involves microwave beams going from the Earth to a satellite. And it was found that the time of travel depends, and therefore the speed of light, depends on whether the satellite is approaching or receding.
Yeah.
We're talking a 50 nanosecond change, which happens to be significant. All the people who work for GPS and are on the inside track know that this 50-second correction needs to be put in, otherwise planes will crash. And they do it, but officially they are using what is called a solar barycentric reference frame, but what they don't tell you is that they program it to coincide with a geocentric reference frame.
This is a fabulous story.
And nobody knows this except the insiders.
And it was because of the insiders that we found out about
Yes.
it. It was covered in Galileo was wrong.
So,
this was just amazing because actually Ron Hatch is a very close associate of Ru Young-Wang, and Ron Hatch was in the Principle. And Ron was one of the guys working with Ru Young-Wang who discovered that, okay, everybody knows they use the Earth-centered inertial frame for the GPS. Why wouldn't they? They're dealing with the Earth. But they always said, but when on these deep space probes like Voyager, well, then we use the solar system barycenter. Oh, well, gee whiz. It turns out that they then rejiggered the formulas rejiggered to render them Earth-centered inertial. Okay, it's just amazing. There's a whole movie to be made there in itself. Let's go ahead and let me just say, I am certain that the questioner means the Allais effect, Allais, Maurice Allais' experiments with the paraconical pendulum. Are you familiar with them at all?
You know much more about that.
I actually am quite interested in the Allais effect. What this boils down to, this French, I believe he won a Nobel Prize in economics, if I remember correctly. But he was always a physicist. He was an experimentalist, and he conducted amazingly long series of experiments with a paraconical pendulum in eclipses, and was able to document amazing anomalous behavior of a paraconical pendulum in conditions of the eclipses, particularly. I think it's fascinating stuff. I think it ties in with even more fascinating stuff. Simon Scholl's work in Russia, where he has determined actual periodicities and decay rates of atomic particles tied to astrophysical properties. So I'm afraid, folks, this is all the time we have. Dr. Smith has so much on his plate, and thank you so much for giving us this special treat. You guys were great. The questioners were fantastic. And don't forget, Bob Sungenis will be bringing something to the table for the flat earther in your community or your family. I mean, everybody's got one now. So keep an eye open for that. From here at the Principle, we thank you for attending, and God bless you one and all.